Hey, we're bringing it on home with the end of Module 4, and we've been focusing this whole module on a huge topic on proportional relationships, okay? And so we started out thinking about finding the rate of change, and we did that by first figuring out unit rates, and then we started talking about, all right, well, what if I have a whole table of values, blah, 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 coming along here. And now instead of just looking at one particular incident or one particular data point, if I start looking at this whole sequence, can I determine if there's a constant rate of change? Because then I can get an equation and then I can graph it and so on. And so what we've been focusing on is taking that y value, which is the dependent variable, making a ratio with the x coordinate or the x value, which is the independent one. And if I take and calculate, if I calculate the unit rate for each one of those situations, I can tell if they are all the same, then it's proportional. I have a constant rate of change, and I can write the equation this way, where this number that is the same each time kind of looks like the magic multiplier that comes along and gives you each one of those y values from x. So here we go in 4.3. We are going to really focus today on graphs, all right? And how can I use graphs to, one, identify if a graph is showing us a proportional relationship, and then use that graph to analyze it, all right? Now, I didn't really give you room here to get any vocab like what's a proportional graph or so on, but sometimes the picture's worth 1,000 words. So can you find a spot to squeeze this in? And I want you to draw 3 first quadrant graphs here, because usually we're focusing on real actual data where everything is positive values, okay? So the thing about a graph, and if it's proportional, is that the graph needs to be 2 things: straight, one continuous straight line, and it must pass through the origin. So it has to go through 0, 0. Okay? Those are your 2 big criteria. So if I have something that looks like this, as I'm graphing all my points, you'd ask yourself, is this straight? Yes. Does it go through 0, 0? Yes. Therefore, this is proportional. So I could grab those data points off of there. I could write the equation, y equals some value k times x. Okay, so that's what a proportional graph looks like. If I gave you something like this, then like this, and then it went like this, and like this, and like this, you'd say, well, it does go through the origin. I satisfy that criteria, but this definitely is not straight. So this one is not a proportional graph. Let's say, what if I had something like this? It looks like this, with a bunch of data points like this. And you would say, awesome, this is a straight line, but it does not pass through the origin. It's shifted up by some sort of criteria, so that for this one, as well as this one, these are not proportional graphs. So you need to watch and take a look at what the picture tells you to give you those 2 criteria. All right, so let's take a look. All right, before 1994, the shower heads used a ton of water. Okay, it was just like a big fire hose coming down at you. And I'll be honest, it felt kind of nice. Warmed you up quickly. 5 gallons of water per minute. Is the relationship between the number of gallons of water and the number of minutes a proportional relationship? Well, first, if I look at it as a table, minutes. 1 minute gives me 5 gallons. 2 minutes would then proportionally, let's see, that would give me 10 gallons. 3 minutes, 15 gallons. Holy cow. Holy cow. Can you kind of see what's happening here? 5 gallons of water a minute. Can you imagine that? That's 5 gallons of milk, okay? Those jugs, that quantity, except in water, being dumped on you. So if you're in there for 3 minutes, you are using 15 gallons of water. Holy mackerel. This, based on this table, so if you use 35 gallons of water, can you figure out how many minutes that was? Or if you're in there 10 minutes, oh my goodness. Oh my goodness. Is this a proportional relationship? Yes, because every time I take my rate of change, the y value divided by x, I get 5 over 1. 10 over 2 is equal to 5 over 1, which is equal to 15 over 3, which is equal to 35 over 7, which is equal to 50 over 10. Okay? Yes, we have a constant rate of change. Constant. Oh dear. Constant rate. I'm trying to go too much at once. And that particular constant rate of change, that constant happens to be 5. All right, so now it's asking us, write this in ordered pairs. So 1 minute gave me 5 gallons, 2 minutes was 10, 3 was 15, 35 gallons gave me 7 minutes, 10 minutes, 50 gallons. Go ahead and plot these ordered pairs. 1 is 5, 2 is 10, 3, 15. I didn't have a value for 4. I had to jump all the way out here to 7 and get to 35. And at 10, we were here at 50. Okay, if the shower head is used for 0 minutes, meaning you haven't even turned it on yet, how many gallons of water have you used? None. What ordered pair represents this situation? That's 0, 0. No minutes yet, no gallons of water. And this is called the origin. So in theory, even just seeing that if I was able to take a straight edge, these would all lie on one line, and therefore it is proportional. If you included the table to include 23 minutes, so if I could go way out here, would this be on the graph? All right, well, let's think about it. If I went out 23 minutes, I'd have to extend it way up, and notice that I'm using different scales. I'm going by ones on the bottom here, but I'm going by fives this way. Would this be on the graph? Well, let's check. My constant rate of change is 5. 15, carry the 1, 10, 11. So would this point be on my graph? No. The point should be, See, I think and I don't write. My hand doesn't cooperate. The point should be 23, 115. So that is why. All right, let's look at another one. Boom. Can you tell if it's proportional from a table? Well, let's see. The house cleaning company charges $45 per hour. So $45 for 1 hour. This is my rate, and I'm going to apply that to situations. So 1 hour, remember this is X, which goes on the bottom, and this is Y, which goes on the top. $45. There we go. For 2 hours, that would give you would charge $90. 3 hours would give us, all right, I'm going up by 4 fives, $135. Write the ordered pairs, okay, where we're going to put time, that's our X value, and the cost is the Y value. 1, 45. 2, 90. Please make sure you put parentheses around each of these ordered pairs. Now, when I look at the ordered pairs, I don't have scales on here yet. Now, since my X values go by onesies. I think I'm going to leave these as onesies. 1, 2, 3, 4, and so on. Okay. But the cost here is, okay, and this was hours. Make sure we label it. The cost, let's see, we have to get to at least 135. 6, 7, 8, 9, 10, 11, 12. Ugh. I don't even know if going by tens, would tens make it work? I think if I went by tens, I'd only get to 120. So I think I'm going to go by 15s. 15 and then 30 and then 45 and then 60, 75, 90, 105, 120, yeah, 135, 150, 165, 180. Okay, let's plot these. 1 hour, $45. 2 hours, 90. 3 hours is at 135. Take a look at this. If you could take a straight edge, would these line up on a straight line? They should, because their constant or their rate is 45 to 1 each time. And it's kind of like I'm going up $45 for every 1 hour, up another $45 for every 1 hour. And if you connected these and used a straight edge, that would make a straight line. Now, does it go through the origin? If you connected this line, it does. If you did not start cleaning yet, how much money would you charge? Well, nothing. Okay, so is it proportional? Yes. You have a constant rate of change. That K value happens to be 45, and it's a straight graph, and it goes through the origin. The big thing is that this has a constant rate of change as 45, and you could write this equation as y equals 45x. I just jumped ahead and put it right there. All right, look at another one. Jared rents bowling shoes for $6, pays $5 per game. Is this relationship a proportional relationship? Well, if I started calculating my constant, or I should say my rate of change, I would get 11 over 1, because remember, this games is x. I would get 16 over 2. Ooh, that simplifies to 8. I'd get 21 over 3, which is simplified to 7. These are not equal to each other. Okay? You're going to say no. And let's show you what that looks like on a graph. Even though if I didn't have any games, notice I still had to fork out $6 for the shoes. Watch what happens. At 1 game, it's 11. That's about there. At 2 games, I'm paying $16. At 3 games, I'm paying 21. 4 games, I'm paying 26. This appears to fall on a straight line, but notice something. I end up with this not going through the origin. You have to pay $6 for the shoes, and you haven't even played a game yet or bowled a game. So no, even though it appears to be a straight line, I do not pass through 0, 0. Okay, so we would say 0, 0 is not on the graph. And that's because of we have to pay $6 before we've even played a game. Look at this one. The bicyclist is traveling. Okay, the time is in hours. This is your x value. Distance in miles is the dependent variable. That's the y value. Let's see. First, 4 and 60. That's this point right here. What does that represent? Okay, what that represents is that this bicyclist traveled 60 miles in 4 hours. If I figure out that particular rate right there, you'd take 60 over 4, and that represents 15 miles per hour. Is that the same for all these other ones? Well, this point from the graph kind of looks like 15 over 1. This point looks exactly like 230, which would give me 30 divided by 2 is 15. This one appears to be 3 and 45, along with 4 and 60. And this point right here, it looks like it is 6 hours and 90 miles. If we calculated each one of these rates, we would get 15 over 1 each time. This is a straight line. Does it go through the origin? Okay. Yes, if I haven't started biking yet, I have not traveled at all. Write the equation in this form. It's y equals that constant 15 times x. Cool. Look at the next one. Concert tickets purchased and total cost. Let's see if you can come up with a relationship. So I see this ordered pair. One ticket, that's my X value, cost $20. Okay. 3 tickets cost $60. 4 tickets cost $80. Some of you might prefer a table if you want to do it this way. X and Y. 1, 20, 3, 60, 4, 80. Some of you might like vertical tables. We call them sometimes a T-chart. Looks like this. 1, if I could write straight, that would be really, really helpful, wouldn't it? 1 and 20, 3, 60, 4, 80. When you go to calculate a rate of change each time, 20 over 1, 60 over 3, 80 over 4. Every single time you should get 20, meaning these are all equal. That means this value, that rate 20 over 1, is your K value or your constant. Okay? Write an equation. Y equals 20 times X. Tickets times 20 gives me my cost. The number of tickets times 20 gives me my cost, $60. 4 tickets times 20 gives me 80. That's because your rate is 20 over 1 or $20 per ticket. Yay! Oh, that's it. Oh, my stars. I think you are proportional masters. What I want you to do is check Schoology for your assignment. And as always, may the force be with you.